Okay, well, welcome, Christine, and welcome, y'all. Christine, this is a series. I told you a little bit about it on email, but you're our fourth guest on this series. We had Lee Mackholtz, who's the director of GIS for the city of Missoula. We had my colleague, Zach Hoyleman, who does a lot of drought monitoring, and you probably know his work from the hydrology community. We had Kimothy, Maureen's partner Timothy Smith, which needs no introduction. You, and then next week we've got somebody coming at us from Onyx Maps, which is based out of here in Missoula, which is cool.
Oh, yeah. My husband uses that for yeah, trip planning.
We're all using it for all various things, so it's
Yeah.
pretty exciting. Well, thank you so much for joining us today. The way that these go is all of the students in this class, and this is an advanced GIS class, sort of the second in a two-course sequence on ArcGIS. But our students in this class come from all different majors, undergrad, graduate students, post-bac, and all different points in the GIS certificates. So our students have all submitted questions for me to ask you. So the way this is going to work is I'm going to do a brief introduction, then I'm going to go through just an interview, and then at the end I'll try and save about 10 minutes for us to have questions all together. Does that sound good? So Dr. Christine Albano is with us today. She's an assistant research professor in hydrology from the Desert Research Institute. Her research centers on better understanding the impacts of climate variability and extreme events on human and natural systems in the Western United States. I know Christine from working at the Desert Research Institute and us getting to do some projects together called Native Waters on Arid Lands. But Christine has really done some amazing work focused on atmospheric rivers, and the project that you all got to engage with, the ARkStorm and now ARkStorm at Tahoe 2.0 project, which is really focused on these large atmospheric river events and even larger events than perhaps we've seen historically. That event in the 1860s is one example, but modeling these really large millennial scale events, and then going through a scenario planning process with stakeholders from the Sierra Nevada area. The team is now engaging in an expanded community with ARkStorm 2.0, which incorporates new modeling capabilities. So I'm going to dive right in, Christine. One of the things that we really like to talk about in these interviews is to give you a chance to just talk about your history with GIS, and in your history getting into the research that you do. So the students want to know, what kind of degree backgrounds do you have? What's your history, and what prompted you to explore hydrology?
Oh, yeah. Well, yeah, those are fun questions, and just your question about how I started out with GIS is, yeah, pretty fun too. So I have during my bachelor's degree, I was studying biology and environmental science in Salt Lake City, Utah. And I got a job as an intern with the U.S. Geological Survey doing water quality assessments, and in particular, the biological part, so looking at fish, aquatic invertebrates, and algae as indicators of water quality conditions in streams around the Great Salt Lake basins. And I was mostly a field scientist and loved doing field science. And I actually remember my boss telling me she knows how to do GIS, but she doesn't tell anyone because she wants to be out in the field and not stuck in front of a computer. And so I kind of took that to heart and thought, yeah, I want to be outside. And so I didn't really, invest time in learning how to do it. Although I was helping to digitize streams and rivers. I think it was ArcGIS 3, and I was doing it on a drafting table. It was a very different setup from what we have now. And so yeah, after that experience, I was interested in going on to study stream ecology as a graduate student. I went to Colorado State University. Again, much of my work was field focused, and I didn't really want to, stray away from that or be stuck in front of a computer. And so I wasn't doing much in terms of large landscape analyses or using ArcGIS to any degree. It was when I got into the work the work environment where it started to just feel essential to have that perspective, to be able to look at maps, to understand more than what's going on just at one single location, but to sort of integrate this landscape scale. And so from then on, I've really very much evolved into what a landscape regional scientists focused on ecology and hydrology, and ArcGIS has been fundamental to that, as has learning how to code in R. Really just sort of expanded my abilities and the kinds of questions I was able to ask. Google Earth Engine as well. I'm sure you all know this and have experienced that, but I think that's kind of my path in terms of spatial analysis. I'll leave it there.
The Desert Research Institute is sort of a different sort of place, and I haven't talked to the students very much about it, but can you tell us a little bit about how you ended up there and how it's different than your traditional university setting?
Good question. So, I will also mention, after I finished my master's degree, I worked for a nonprofit called the Grand Canyon Trust. That's where I sort of started to get my GIS experience. And then I moved out to the Truckee, Tahoe area and got a job with UC Davis. I had a master's degree and I was doing work with the Southwest Climate Science Center, which is how I was introduced to atmospheric rivers. Never heard of them before, but when I learned that these are just such a major determinant of water and ecological systems in the West, I was enamored, and that's what I ended up doing for my PhD. I'll say that while I was at UC Davis, since I had a master's degree and not a PhD, I felt that there were limitations in ways that I hadn't felt when I worked in the nonprofit sector. In the California system, you really have to be a PhD to write a proposal. And so I found that I was writing proposals and putting other people's names on them so that I could get funding. And from there, I decided I need to go back to school and get a PhD. And so I did it at UNR since I already lived here, and worked with Maureen McCarthy, who is how I know Kyle, and Michael Dettinger, who is an atmospheric river scientist who was working at USGS. And my affiliation with DRI started with my graduate degree, but it was a place that I knew I wanted to stay because I live here and didn't want to go somewhere else. And DRI is unique in that we have, it's an academic institution. It's associated with the Nevada system of higher education, but we're not a typical university. So we don't get tenure. We have to raise our own funding through grant applications. We get some money from the state to support the institution, but it's all research for the most part. We can teach at UNR. We have affiliations with UNR, so we can teach and advise students as we want to and can, but it's really, the difference is, again, we have to bring in our own funding and research. And to me, I really love that aspect of DRI. I feel like it's a perfect fit for me because I want to do research that is applied, that isn't necessarily sort of ivory tower theoretical. So it's unique in that way, I think.
Yeah, it's definitely a special place, and really, really hard-hitting research is done there. And the ARkStorm series of projects is a good example of that. How did you get involved with I don't think I know this. How did you get involved with the ARkStorm project initially? Did you conceive of that project with Mike? Tell us that story a little bit.
No, so the ARkStorm project was something that had started, I'm not sure exactly, probably like 2008, 2009-ish. And this was led by the US Geological Survey, multi-hazards demonstration project is what it was called back then. And they had done several of these kinds of scenarios. They did one for earthquakes. They've since done one for a tsunami. And the idea is they bring in hundreds of scientists to, develop the scenario and look at its impacts to natural resources, to water, to ecology, to people. It all gets bundled up into sort of what does this ultimately cost? So they had developed this scenario for the state of California, and they did it by just taking these two historical storms, one from 1986 and one from 1969, I think, and just said, what if these just happened back to back? Instead of in separate years. And the idea was to create something that was sort of on par with the 1861, 1862 floods, but didn't really have to involve climate change. I think, at that time, the acceptance of climate change was, still growing. And so it was easier to just have these discussions, say, without bringing that in. So this could happen. It's happened before. Climate change makes it more likely to happen. So that scenario had been developed for the state of California, and when I was working for you at UC Davis, I was up at the Tahoe Environmental Research Center, where Maureen McCarthy was the head of the Tahoe Science Consortium, and Mike Dettinger visited. The USGS wanted Maureen to sort of downscale this scenario to a local community in Tahoe. They were concerned about the fact that, this is an important place for both the states of California and Nevada economies. They wanted to see what ARkStorm might become in a mountainous environment with snow, with a lot of rural areas, and those kinds of things. And so, Dale had funding that he gave to Maureen to do these stakeholder engagements around ARkStorm and just really bring it down to the local level and talk with people and say, hey, what keeps you up at night about this? And so at the time, I was still sort of doing ecological research and I've sort of became enthralled with atmospheric river science, as I said before. And at the start, I was interested in how it related to ecosystems. And so one of the papers I ended up doing for my PhD was looking at how atmospheric river rainfall relates to vegetation growth and fire in the Southwest. But I have to say, after working on the ARkStorm project, where we were engaging with communities, and there was a lot of energy and excitement about, and maybe stress about what this scenario might do to the region, because there had been a series of storms in 1997, and a lot of people remembered that. And so I have to say, I started as an ecologist, but this project was pretty transformative for me in terms of just, understanding more about the impacts to people, which most people think that's more important than plants and birds, but I was a little slow, I guess.
Well, it really illustrates how these impacts to people are driven by the impacts to all of those other ecological systems. And in fact, just pivoting a little bit to the ARkStorm projects and the process of gathering all of those data, students in this class are all doing projects where they're having to gather a lot of data and are seeing firsthand that it's difficult to conceive of what data needs to be gathered for a particular presentation, a particular project. And we can only imagine that for ARkStorm, where it was not only the meteorological data, but it was all of those impacts, secondary and tertiary impacts from those. Can you walk us through the process of gathering those data? It must have been iterative.
Yeah, and I would say so. When we did ARkStorm at Tahoe 10 years ago, we had Toby Wellborn, who worked for the USGS, was our GIS guy, and he he did a lot of the data gathering and work. But yeah, this in 2013, we didn't have the data resources online that we have now. So he, pulled together data that he could on hazards and where schools are and those kinds of things. But yeah, I can just say it was not readily available like it is now. And we made maps that we printed out and hung on the wall. and and yeah, that landscape has changed considerably. I think yeah, even then, I mean, Toby was having to go to individual people to ask for data. It's not like there was some central location. A lot of the data related to natural hazards is for official use only. So, the public doesn't necessarily have access to those data, which, was problematic in terms of us trying to understand what the implications of this storm might be. Yeah, I think that California had developed some landslide hazard data as a function of ARkStorm, but we didn't have it for Nevada. And so, yeah, it was very piecemeal, I would say, pulling that together. And this time around, it's been amazing what we have access to. There are tools online through FEMA that have all the hazards and climate projection information overlaid. There's a lot we can do now for understanding the social and economic and ecological impacts of these events that we couldn't before. And so as part of this 2.0 effort, I've been working with Eric Jensen, who developed this application that allows people that we're talking to who don't have experience in GIS or big data to easily zoom in and out as just fodder for like thinking about what something like this might do on the ground, or how it might impact them. And so we've just had one meeting so far, and the app is still very much in development, but I'm very excited to see what comes of that. We haven't done that before, and I'm excited to see.
It's nice to be able to go from that place of having to be just focused on gathering data and bringing people data that they've simply never seen before, to now organizing it in a way that's really useful for people. And that has its own iterative process. And you just started talking about that a bit. You've had one big stakeholder meeting so far on this project.
Yes.
We've all gotten to look at that draft dashboard. What do you think you're going to change?
Oh, well, we've already gotten some feedback, and I'd be interested in your all's thoughts on this. But I mean, some of the low-hanging fruit was the color scheme. So the color schemes need some work, and National Weather Service has a color scheme that they typically use that I think is has more bins, so allows more detailed, higher resolution visualization of those gradients. That's something will definitely change. One of the things that we'd like to do is have a page that somebody can go to a day of the scenario and just have a summary of, this is what's happened so far. This is the forecast. This is what's coming. And that will be, I think, an important tool for tabletop emergency exercises where the emergency managers do this, probably a few times a year for different kinds of things they want to be trained on, like how to better communicate with each other, or how to find the best route to one place or another. And so we're hoping this tool will be helpful for use in those kinds of scenarios where they can say, okay, this is the information I have. This is what we need to do next.
So getting into the weeds a little bit, I mean, the dashboard that you shared was developed in Shiny framework with R. It's pulling data, my understanding, from Earth Engine, right? From Google Earth Engine. What tools would you use for the types of sort of scenario snapshots? Are you going to be doing story maps, or what do you think you might use?
That's a good question. I mean, we have limited resources, and so the
Mhm.
thought was just to have another report tab and like
Got it.
have just a 2-page report with some maps and
Mhm.
simple pie charts. Like just we don't want to do too many charts and graphs because most of the people we're working with are not necessarily so maps are good, and yeah, just kind of very basic information about the status of different systems. Um, yeah, I'll mention that we had started out with a Google Earth Engine app.
Mhm.
I may have shared that with you. It just had the meteorology, and the nice thing about that was that you could, click on a point and pull a time series and
Mm.
see,
See a
how
graph.
much precipitation had happened there. But it was a little slow, and we wanted to do more complex kind of reporting and summaries. And
Mhm.
so that's why we switched over to the Shiny R app. And what we have in there now are just image tiles. So you
Mhm.
can't click on a point and get the time series. And I think we are probably going to go back to something that is
Oh,
more interactive, because I think everybody wants to just be able to hover or click on something and see, oh, how deep is the snow on top of
yeah.
that building?
Yes.
And so that's definitely on the high priority list. Um, we're hoping to get inundation, flood
Mhm.
inundation maps for the whole state of California. And so those will eventually go in there as well. Um, yeah, there's a lot we're still kind of trying to grapple with in terms of we have some data that are just for the Tahoe Sierra Front region and other data that are for the whole area. And so trying to figure out how to organize that as more data come in is, yeah, something I'm anticipating having to
Some
do.
some of those inundation maps that you shared for the Reno Sparks area and everywhere along the Truckee were really eye-opening when it was like everything east of Reno got flooded in the valley there.
Yeah, yeah. And I mean, the interesting thing about ARkStorm is uh, so we have the 100 and 500-year flood boundaries in there as a reference point. So that's
Mhm.
another thing we try to do in these visualizations is we want a reference point that people can relate back to. So 1997 flooding is in there. And then, 100 and 500 year is something maybe more engineers can relate to.
Mhm.
ARkStorm, the peak inundation that we had in the map, we will have a time series soon enough. But it was somewhere between the 100 and 500-year flood in terms of depth. But this is a 30-day storm. So the difference is that water stays there for a very long time,
Right.
on the order of a couple of weeks. And so we expect there to be different impacts because of
Mhm.
that duration. And it's something, again, just, yeah, to help. I think,
Yeah. Yeah. Well, and it helps for people to see those impacts and start thinking about what they would need to do in terms of planning for them, right? And that's the purpose. What sort of outcomes did you see from ARkStorm 1 in terms of the risk management, hazard mitigation, and emergency management side of things? And then what are you hoping to see in ARkStorm 2? Like, are there some areas that you think just weren't addressed because that part of the story wasn't really told in ARkStorm 1?
yeah, yeah, absolutely. So some of the things I think we got out of ARkStorm 1, we brought a lot of people together that didn't normally talk to each other. And so developing those communications and relationships through these workshops and the exercise, I think was a really important, outcome
Outcome. Yeah.
from this. In the Tahoe Basin, they learned, for example, that most of the people who manage water supplies and wastewater plants in the Tahoe Basin actually live in Reno, and
Hmm.
so they need to keep those running essentially to serve the people in the basin, and so one of the things that I think they did was they planned to have people, stay longer in the basin, keep more propane up at their sites in cases of these kinds of storms. Yeah, what else? Yeah, just these small things that kind of help be pre-position resources and people to better manage the flooding and snow.
Sure.
2.0, I would say, I mean, some of the things we missed in the first one is, well, a lot of people have moved to Reno since, yeah, even in the past 10 years. And many of them are now living within, the flood, within the 100-year floodplain. And in 2017, we had, and 2023 to a less, 2023, we had a lot of snow. 2017, we had flooding, and there were places that hadn't really been on anyone's radar because nobody lived there, in 1997, but these places were flooded really severely as, neighborhoods were built up. And so there are a lot of lessons learned that are, from storms we had in 2017 and 2023, changes in our communities, like, more people living in the wrong places. I think, we missed, there are communities that we missed. And we'd like to, one of the focuses of this is to really be working with underserved communities and looking at, socioeconomic impacts more closely. And then I'd say this time around, we have a lot more cool models, and we have an app and, all of these things that allow us to dig in deeper to what the implications are that, we didn't have available before.
Yeah, it's just going to better allow people to imagine the implications of these large events. This winter, you all had some, at least one or two big AR events. Now, nothing on the order of magnitude of what you're talking about in ARkStorm, but they were big events. Did you get any feedback during those events when there was 12 feet of new snow at Tahoe? Like, we were better prepared because of ARkStorm, even though this is a small event compared to those? Or
yeah, I mean, we did a retrospect. So 2017 was a big year. We had flooding, and there was a retrospective. We did a retrospective with a number of people who had been involved in the first time around. And some of the things I mentioned, like having people in place and resources in place that helped them in 2017 was really valuable. I think some of the folks we talked to had never heard of an atmosphere. Most people hadn't heard of an atmospheric river in 2013. But introducing them to that concept in science, I think, was helpful in terms of them understanding what the key flood hazard is in our region. I know ARkStorm was used in some of the hazard mitigation planning for Tahoe and other places, but I mean, I would love to go back and I will say ARkStorm 2.0 is our opportunity to hear from those people who were involved the first time around, hear more about what they learned and or didn't learn, and build from that.
You sort of alluded to this earlier in your comments, but you said that in ARkStorm 1.0, you didn't really belabor the climate change angle to this. It was sort of not as politically accepted, and so on and so forth. That seems to have changed, at least in some subtle ways. Are you all bringing that in more in ARkStorm 2.0 and talking about the changing likelihood of events like these?
Yeah. I mean, one of the reasons for, so Daniel Swain, who has the Weather West blog, if any of you follow that, he and Xingyin Wang are the ones who created this. And yeah, the idea was like, we really need to think about this under climate change conditions. And so while the first ARkStorm was just stitching two historical storms together that we took from, the existing meteorological data.
Mhm.
This new scenario came from climate model projections. They ran several simulations of the same model to find something that was more extreme across the state of California. And then they downscaled it using the weather research and forecasting model to get it at a fine enough spatial resolution. So it's 3 kilometers, which is arguably not it's still pretty coarse for mountain regions, but the idea was to get at something that we might plausibly see under climate change. And I know that Daniel has done some statistics to look at how, that compares to what we've seen historically and what the probability of something that big might be with warming temperatures.
Are you having any backlash from policymakers or planners?
Not to date, however, I will say some of our emergency management partners, they still just would rather talk about, they'd still rather not pull climate change into it. It can be counterproductive and distracting. And, this is a climate change version of a storm, but it's not always a central focus just because still, there are, there's some hesitation to just frame it in that way. I think it's less productive in their opinions. So, it's interesting.
I want to ask this one question. Philip asked this, and it was a really good question. In the report on ARkStorm 1.0 that you authored, you talked about a lot of the secondary impacts. One was surface water contamination from sewage and those sorts of things, and that was really interesting. But one thing that we couldn't find in there, that Philip couldn't find, and I couldn't find it either, was a focus on groundwater contamination. What sort of impacts do we see from industrial, agricultural, other sources of groundwater contamination during events like these, as potentially contaminated surface waters get spread across the landscape and then seep in places where you don't have the natural filtration systems that you might get in wetlands? You know what I mean?
Yeah, that's a really good question. I mean, that wasn't something that we were looking at much. I'm sure there's infiltration in between Tahoe and Pyramid Lake, which is where the Truckee River ends, essentially. And, I would say most of the path is kind of steep mountain environment where it's moving pretty fast. I'm sure there's some groundwater recharge. The sewage, the big issue was sort of sewage and waste, and that was going into Pyramid Lake, and that's what we were most concerned about. Groundwater was not on our radar for that. And I don't know if, the nature of the contaminants, I guess
would really be a challenge for that system.
Yeah.
Are there any other secondary impacts of these large events that you didn't consider in ARkStorm 1 that you are considering in ARkStorm 2 because of that feedback, or because of, people just thinking up things? Oh, well, I wonder if this system's being impacted.
Well, I think one of the big issues and hot topics in atmospheric river and flood research is, this interaction between fire and floods. So post-fire, we have, as you all know, a lot of our landscape is burning, some at high severity. And so if we get an atmosphere, our fire seasons are expanding. So when we have that bumping right up against a large atmospheric river, for example, post-fire debris flows, increased flood risks, that's definitely something that's on a lot of people's minds. We didn't look at that last time, but that is something that we will be this time around. So USGS has done a lot of research on this, and I think they've actually ran this ARkStorm scenario through some of their post-fire debris flow models. A storm like this that was selected for its long duration, may not be a huge post-fire debris flow trigger, because what it takes for those is really high, like 15-minute precipitation rates. And I think, because it's a model, a 3-kilometer resolution model, we may not be getting those kinds of intensities just because it's a coarse model, and it wasn't selected for that reason. But that's definitely on people's minds, and wasn't necessarily last time around.
Got it. Well, I have to ask this last question before we move on to questions from the class. But atmospheric rivers didn't really enter our lexicon up here in Montana until 2022, when we had the Yellowstone floods. An AR event came across over snowpack that was primed for melting, and we had this catastrophic flooding event. Several students, Georgia, Malachi, Philip, they all asked variations on the same question. Do you have plans to adapt this model to other regions where some data are suggesting that we're seeing more of these atmospheric river events, that we haven't really seen as many of them before, like the Northern Rockies?
Yeah, that's a very good question. I've been asked that question like a few times in the past month, or something on the order of that. And so, yeah, I mean, the Yellowstone event was amazing because, it was in June.
Yes.
Yeah.
Yeah.
It was in June, for one.
Yeah.
And for two, it was an AR5, which is, so there's a ranking system of ARs, 1 to 5, 5 being the most extreme, having the most water vapor transport. And those are rare. And getting one of those in summer is,
Yeah.
It probably has happened before, but not since I've been paying attention. And so, that was pretty amazing. I mean, the thing about atmospheric rivers is we have all of these different algorithms for detecting these large features. And there are criteria that are applied to say whether it's an AR or not. Oftentimes, once an AR gets in, like it wasn't an AR5 by the time it got to Yellowstone, it might not have even technically been an AR anymore, but clearly that was the source of the water. And so that's a direction the science is going, is how do we better attribute these inland impacts we're seeing from ARs that, there are ARs on the coast, they're no longer by the time you get inland. I mean, that's maybe an aside to the question you asked, but I think it's an interesting direction that the research is going. And I would say, yes, these kinds of scenarios would be very relevant. And I think they should be used in more inland regions where, we can get these extreme storms. It's maybe it's not, on the southeast coast, it's hurricanes.
Right.
But once we get, up into your region, there's a mix of things that can create those extreme.
Right. The parade that we had last winter of AR events that hit the California coast, they had big precipitation implications in a big diagonal swath all across the country. I mean, all the way up to Minnesota. We just had this diagonal of a lot of excess moisture. And that was, it was pretty wild.
Yeah. There, some of the earlier research on these. So John Rutz, who was worked for NOAA for a while, he his research on inland ARs was pretty formative in terms of he found these tracks. So basically, if it's coming straight on in Central California, our Sierra Nevada mountains just block it and it doesn't go anywhere, but they can come up from the south or Baja California, as well as to the north of the Sierra Nevada, and they can travel quite far inland.
Got it. Well, I want to give folks here an opportunity to ask questions as well. I may have to repeat the questions. I'm not sure how well you're going to hear from the audience because I don't have like a boom mic or anything. But does anybody have any questions for Dr. Albano? Oh, come on. I didn't ask all the questions that were on my list here. All right, then I'll ask another. Oh, Philip, thank you. You're always a go-to. Thank you.
I know we talked about, you mentioned the atmospheric rivers that hit California earlier this winter, but I was curious as to how those events actually compared to the events in 1986 and 1969.
Did you hear that question, Christine?
How do which events compare
How
to
did-
1986 and 1969?
How did the AR events from this winter, especially the big snowpack events high in the Sierra, compare to those two events?
That's a good question, and I I have to say I don't know. I mean, I think that those 86 and 69 events were long, so they were over a week long. So that, yeah, I don't think this past winter we necessarily had those long, drawn out storms. Maybe more like in, I mean, 2017 in California, we got a whole ARkStorm over the course of the entire season. It just kind of trickled in more slowly rather than coming in over the course of a month. But yeah, I don't even know. I have to say, I don't even know what those ARs would rank on an AR scale. I'm guessing they were like 3s and 4s. But I'm totally gonna look because yeah, that would be a good point of reference.
Christine, I've got a question then that's drawn from the students. What do you view as essential skills in GIS or otherwise for people who are interested in careers in hydroclimatology, hazard planning, or emergency management of the sort that you've gotten to engage with?
Yeah, I mean, I think learning how to program is, when you're doing hydroclimate, you're working with a lot of lots of data, spatiotemporal, and so learning how to program in R or Python, or I mean, those are what I know. Yeah, like I said, it really helped me to scale the kind of work that I do. Listening to people and interacting with managers and stakeholders if you want to be doing applied work, like, yeah, I feel like I get the most fodder for research when I'm just listening to what people are saying about the challenges they're having, or the problems that need to be solved. So yeah, programming, listening, and yeah, I mean, being able to communicate in writing.
Yeah, all those things that you learn in college.
Yeah, all those things. Yeah.
I've got Jack over here. I don't know if this is on you, Jack.
Yep.
Yeah.
Okay,
Good.
I'm just curious if you could maybe go over some challenges that you've had to overcome on your path for like research or your field work or even where you're at now.
That's a good question. Yeah, for me, I think one of my challenges was just not having the confidence to move forward with research ideas that I had, and just learning I think talking with other people more about those ideas and getting feedback was an important sort of lesson that I probably learned too late. Yeah, I'm trying to think what else. Yeah, I mean, I would say when I worked for the nonprofit in Arizona, the Grand Canyon Trust, I learned that my position was one that was both science and advocacy. And I would say that I learned that I am not a great advocate. I'm a much better scientist. And so, yeah, having experience with different things and learning what you're good and not so good at is useful. Like just, trying out a bunch of different things. I've worked for the federal government. I've worked for a university. I've worked for a nonprofit. And I finally found my place, which is at this sort of research institution that isn't necessarily teaching and education, but is still affiliated. So yeah, trying different things out, I think, is an important way to find your way. I don't know if that might not answer your question, but
I think it did. Yeah.
okay.
Well, we've got time for one more question if somebody has one. But if not, I'd like to just thank you so much for joining us for this. It was really insightful. Thank you. From afar.
Yeah, thanks for having me. And I saw your class website and I thought, wow, I want to take that class. So you're all of you consider yourself like, no.
All right. Well, thank you so much, Christine. And I'll see you sooner rather than later, hopefully.
Yes.
Yeah. And I'm going to stop recording